So today we're going to continue on looking at multiplying fractions, but the numbers are going to look slightly different. So if you weren't comfortable with multiplying fractions, but there's a few of you guys in the room who just need a bit more practice, don't worry, you'll get more practice today. And we're going to do three more lessons like this. So eventually it's going to get easier and easier and easier, I hope. So today, before we get going, all right, if we look at these three circles here, and we want to write the fraction for these three circles. Here, the denominator, oops, come on. For these circles, what would it be? Maddie? 4. Because the bottom number tells you how many pieces is each shape broken up into. And the top one is what we're counting. 11. So we have 11 shaded things. So this is 11 out of 4. Right? Then we have a very similar looking one here, except for, let's go over here. Oops. Our two big circles here don't have any pieces. So we saw our last one has cut up into 4. How many are shaded? Good, thank you for the fingers. 3 of them. And the 2 full ones goes in front. Right? So we have 2 holes and 3 out of the 4. Now these 2 fractions that we drew, they look different, but they have the same value. You can tell from the diagram, right? Both of them have 2 full ones and 3 out of the 4 on the last one. Right? So now, we talked about this at the very first set of notes, going way back in October. This is called a mixed fraction, where you have a fraction and you have a whole number up front, and the other one's called improper fraction, right? It is improper because your top number, your numerator, is bigger than your denominator. It shouldn't be that way, okay? So now, you have 2 fractions. They look different, but they have the same value. We need to be able to convert from one fraction to the other fraction without using diagrams. All right? Because if I give you a question that has these mixed fractions in, it's easier to do calculations with this one, improper fractions. Right? So to convert, there's a couple of steps. All right? So going over here, we're going to convert this. So notice the size of the pieces never change. The bottom numbers always stay the same. So here, if I want to convert this to improper fraction, it was out of 3, it stays out of 3. Okay? Now to figure out what the top number is, because we want to get rid of this whole number, is like this. We multiply these together and add this. So we have 3 times 1 gives us 3, and plus 2 gives us 5. So this becomes 5 over 3. Okay? Now, if you want to, for the first few, you can draw these out. But drawing them out takes a lot of work. If I had to draw the first one, it'd be 1 full circle shaded in. And the other one would be out of 3 pieces. So that would be like a peace sign or a Mercedes symbol with 2 out of the 3 shaded in. Whereas the other one would be 2 circles, both cut up into thirds, and 5 of them are shaded in. So 1, 2, 3, 2 on this one, and 3 in this one. So it means the same thing, right? So this 1 means that there's 3 actual pieces shaded in. Is that okay? So you're just going to memorize this. Like you multiply, then you add. The size of the pieces don't change. All right, so let's practice this over here. Let's work our way across here. So, first off the bat, let's go do all of these at once. the 3s, 5, and the 7 don't change. The size of the pieces don't change. All you have to do is figure out the top numbers. All right? So for the first one on the left-hand side, what should the numerator be, the top number? You multiply, then add. Multiply these numbers, we take a trip around the fraction, multiply those numbers, then add the top number. What do you get?
4.
4. 3 times 1 is 3, plus 1 gives us 4. So these two fractions mean the same thing. That's your mixed fraction, that's your improper, means the same. Maddie, what's the next one? Do you know that one?
It's 47.
Yeah, 9 times 5 is 45. Add the 2, 47. Okay, then the last one here. Thank you, Carson. 7 times 3 is 21. Add the 1, 22.
Oh, it's starting to make sense.
Okay, we're going to do lots of these. We're going to do a lot of these. Going in the other direction, a little bit harder. So if I give you like this, an improper fraction, we want to go the other way, right? We want to figure out the top number shouldn't be bigger than the bottom number, so we need to figure out what the whole is. So to do this, what we need to do is first realize it's always out of the same pieces. So the 5 is the same. We need to figure out what the whole number is and the number on top. Okay? So the whole number, it goes like this. How many times can 5 fit into 13 fully? Answer is twice, right? So if you don't know that, you can use your multiplication chart right here. Here are our 5s times tables, right? 13 would be here, in between 10 and 15, so it fits in 1 twice, 2 times. So we go back to our notes. Fits in 2 full times. So because 5 times 2 is 10. But here's the thing. We're trying to get to 13. How many more do we need? We're at 10, and we need 3 more to get to 13. So the top number then is a 3. Because that makes 13. All right? Okay, that's the hard one, right? So let's practice these. So once again, the denominators never change. So this one's out of 5, this one's out of 10, and this one's out of 7. All right? So for the first one, 5 fits into 12. How many times? Thank you, Keaton. 2. 2 full times, because 5 times 2 is 10. How many more do we need? Thank you again. 2 more. Because 10 plus 2 gives us 12. Right? Next one. 10 fits into 32. How many times? Thank you. I see all you guys' fingers. 3. Thank you. Those 3 full times. How many more do we need? Thank you with the fingers. 2 more to make 32. 3 times 10 is 30. 2 more. There. Okay, next one. 7 fits into 28. Rylan. 4 full times. How many more do we need? No. What's 4 times 7? 28. So we need 0 more. Now, here's the thing. It fits in perfectly, so we shouldn't say 0 out of 7. We should just say
1.
No, 4. We don't need that 0. We don't need this. It fits in perfectly. Right? Because remember, a fraction is simply a division statement. 28 divided by 7? 4. 4 perfect times. There's nothing left over. So the answer is just 4. Okay? So now, let's practice multiplying. So now what's going to happen? We're not going to do all these questions. All right? We're going to pick and choose some of them to do. All right. Let's do this one here first. We'll do the one on the right-hand side first, on the back side of the page. If I give you a question that has mixed numbers in it, your first step is to turn it into an improper fraction, just like we just did, right? Convert each one of these numbers. So the 5 stays the same. We're going to have a time sign between these, and the 7 stays the same. What should the exponent, not exponent, the number on top of the 5 be? Keaton?
17.
17, you're right. 3 times 5 is 15. Add the 2, gives us 17. All right? The next one. Multiply, then add. Timmy?
30.
30. 4 times 7 is 28. Add the 2, gives us 30. Okay. So now this question starts looking like what we did last day. Right? We look for top bottom pairs to make this smaller. Right? Or if you weren't good at that, remember you could just multiply the tops and you multiply the bottoms together. So if I grab my calculator and I go 17 times 30, on the top I would write 510. On the bottom, 5 times 7 is 35, and I would try to make that smaller. That would get you 1 out of the 2 marks, right? But I said, hey, let's try to simplify first. Does anybody see a pair of numbers there on the top and bottom that can go smaller? Because that at the end is kind of hard to make smaller. Big numbers we're working with. Hannah?
5 and 30.
5 and 30 can be both divided by 5. So cross these off as a pair. Right? So we're going to divide both of these by 5. So you go 5 divided by 5, we get a 1. Then we're going to divide the other one by 5 as well. 30 divided by 5. Thank you. 6. Oops, that's not a nice looking 6. 6. Now, is there any other top bottom pairs that can go smaller?
No.
No, that's it. Right? So now we multiply the top and the bottom together. We got, sorry, the top and the top. 17 times 6 is 102. And 1 times 7 is 7. So this answer would get you 2 out of 2 marks. The one in blue would get you 1 out of 2 marks. So it depends on what you're comfortable level with, right? Some people are feeling overwhelmed, and this is probably as far as you can get. Other people like, this is easy, Mr. Dhaliwal. Okay, let's do a couple more, because I think you guys got this. Let's try this one here. All right, so the bottom numbers stay the same. Out of 3 times out of 5. All right. Okay. What should the exponent be for the first, not exponent, numerator be for the first fraction? Keaton?
7.
7, you're right. 2 times 3 gives us a 6. Multiply, then add.
That one's
7.
27. The other one.
Other one's 27. 5 times 5 is 25. Add the 2, 27. Okay. Are there any top bottom pairs? We could just multiply the tops together and multiply the bottoms together. That gives you 1/2 the marks right there. So if you did that, let's just do that. If you're at that level, you can use your calculator. You don't have to do it in your head. 7 times 27 is 189. And 5 times 3 is 15. You got 1/2 the marks there. But we want to try to make this as small as possible. Hannah, do you see something?
3 and 27.
Can be divided by 3. So we're going to cross these off as pairs. Right? You go 3 fits to 3 once. And 3 fits to 27 how many times? 9. Okay. Is there any other pairs of numbers that can go smaller? No. Right? So we have 7 times 9 is 63. And 1 times 5 is 5. 63 over 5. Okay? So now, I'd give you 2 marks. Now here's the sort of iffy thing. Shh. some teachers wouldn't give you full marks for that answer. Some people would say, hey, this is an improper fraction. And you want to make it proper, right? Yes, Kai.
12 and 3 over 5.
Good. We're getting there. So, some people would say, let's write this as a proper fraction. So it stays out of 5. And you go 5 fits into 63 how many times?
12.
12 times. And if you don't know, use your multiplication chart. We got our multiplication chart. We got our 5s, hopefully showing up soon. 5s here, and there is 63 in between there. So it's going to fit in 60 times, so that's 12, right? 5 times 12, and go back to here. So 12 full times, 5 times 12 is 60, and then we need 3 more. Now, for the purposes of my class, and every teacher is going to be different, you can always leave your answer for my class like this. Unless I say, hey, give me your answer this way. Technically, these two have the exact same value, right? This is the proper, more grammarly correct way of writing the numbers down. But we always do our calculations like this. So I find this not as a necessary step. It makes a better answer for communicating, right? So now that philosophy there is going to depend on your teacher. If you have a different teacher next year, they may say, hey, you always have to write your answer that way. My background is physics and chemistry and stuff like that. And for us, in those kind of classes, it makes more sense to keep numbers like this. So it depends on your teacher's background. Okay? All right. So let's do, is this easy?
Yeah.
Good. So what would happen in, say, this situation here? Right? One of the fractions is mixed, the other one isn't. So you don't have to change both ones. You only have to change the one that's the odd one out. So the first one stays exactly the same, right? And the second one is, I heard somebody over there say it.
17.
Thank you. 8 times 2 is 16, plus the 1 is 17. Okay. Now, is there any pairs to make this smaller? Yes.
There is one, but there's no point of doing it.
Which one?
1 and 8.
Oh yeah, 1 and 8. One you can't go smaller, right? So, just like before, sometimes there's nothing you can do. So you multiply the tops together. 1 times 17 is 17. 2 times 8 is 16. Don't fall for the trap and try to make 2 and 8 smaller. Right? It has to be a top-bottom pair. Can't be 2 things on the bottom. Can't be 2 things on the top. Yes, Timmy?
The top one's 1 and the side one is 16.
It's not 16, it's 17.
Wait, no, the top one. If we have the top one, like on the right, on the very right.
Yeah.
No, on like a very. Like,
Where am I
that
going?
one's just supposed to be 1, and then the side's supposed to be like 16.
16? Where?
No, like.
Oh, like I don't understand.
Like you know, like when we do like the when we make it proper.
Oh, you're trying to make it proper. Yeah, so I'm not asking you to make it proper. Okay? Okay, let's do one word problem and we'll call it a day. I'll have you work on the assignment. So just like the question from last day, we have a recipe. A recipe calls for 3 1/3 cups of flour. How much flour would you need if you want to make more of the recipe? You want to make 2.5 times the recipe, right? So if you want to make more of a recipe, you have to multiply it, right? So if you're doubling it, you would times it by 2. But you're making 2.5 times, so you can go times by 2.5, right? So now we convert each of these numbers, right? What should be the numerator for the first fraction? Yes, Timmy? 5, right? We multiply this and add. 2 times 2 is 4. Add the 1, gives us 5. What should the 10? Yeah, thank you. 3 times 3 is 9. Add 10. Okay? So, any pairs of numbers? Yes, Timmy.
10 and 2.
10 and 2 can be divided by
2.
2. They're both even numbers. So 2 fits in 10 5 times. 2 fits in a 2 once. Anything else?
No.
No, that is it. So we have 25. 5 times 5 is 25. On the bottom, 1 times 3 is 3. So 25 over 3. Now, with word problems, this is where usually the exception is. Because we don't want to say 25 over 3 cups of flour. That doesn't make sense, right? That's not how we talk about baking with improper fractions. So we would convert this. And you go, okay, let's convert this into a mixed fraction. So 3 stays the same. Keaton.
8 over 1 and 3.
Thank you. If it's an 8 full times, because 3 times 8 is 24. Then we need one more extra to get 25. So we need 8 1/3 cups of flour. And that's it. Right?